Greetings, I plead to Dr. Lim as our lecturer for BJMP 3023 Operation System Design Group A. So by the time you are watching this video, I hope you are in a good condition. So for today, our group 6, will be presenting our Taguchi Airplanes Product Design Report. So before I start, my name is Atika MAISARAH OFIFIANTI binti ABDUL RONI, matrix number 270610, and these are our group members. For today, I will be presenting the abstract and the introduction for our report. Abstract is very simple, yet it contains a lot of information because it is the summary of our entire group project. So in the abstract, we mention our purpose of carrying out this experiment is to demonstrate the Taguchi fractional factorial experiment for product design. We are to determine whether whether the level of factors affect the characteristic of the airplane. So we carry out 81 experiments based on the parameter design, which in the parameter design there are 9 designs, and we carry out 9 repetition for each design. Therefore, that is how we conduct 81 experiments altogether. So the main objective is to find out which design is the best, which can fly the furthest distance. So in other words, we are actually looking for the design that is robust to noise. Because when it is robust to noise, the design is robust to noise, it has less, it minimizes the effect of the airplane with the noise factor. The noise factor here in our project is the environmental factor, which is also the uncontrollable factor, because we can't control the environment, although we have decided which environment is the best and suits for us to carry out the experiment. So after we carry out the experiment, it is found that the paper airplane experiment 1 maximize the flight distance, which is this is the best because it has the furthest distance record. We can conclude that the Taguchi method is suitable to be applicable in our daily life, as we know that we are living in this modern world with full of technologies and gadgets, and which quality is being prioritized. So Taguchi method is very applicable and suitable. This is because the Taguchi method reduces the occurrence of defect and failure in manufactured goods. Introduction is about what is about our project. It is about the background of our project. So before I start with our project background, it is important that we know what is Taguchi method. So Taguchi method is the method that focuses on making quality rather than inspecting quality. Also, it is a statistical method, sometimes called robust design method. So basically, Taguchi method is a method being introduced, proposed by a Japanese engineer, Genichi Taguchi, and he contributes so much to the philosophy of quality. And for him, it is important that we focus more on making quality rather than inspecting quality, which means he focused on having the quality throughout the process first. And when the process is carrying out with a high quality, we will have a good quality result. So, uh, in this experiment, we have 3 approaches, which are the system design, parameter design, and tolerance design. Okay, like as I said before, we are going to demonstrate a Taguchi frictional factorial experiment in this report. First, we'll talk about the system design. So system design is basically creating a prototype of the airplane, and we have 9 designs made to carry out this experiment, which are based on the parameter design. Okay, so here's a picture of the prototype airplanes that we have made. If you look closely, all the planes are different in like the different design. It's the same size, but the shape is different. We are using a 30-gram paper. Okay, next we have the parameter design. This is the table that we use uh, to make our airplane. So as you can see here, we have 4 controllable factors: the weight, location, stabilizer setting, nose length, and wing angle. So what's with all the settings? As you can see, the settings are different. Okay, this is to create variation. The parameter design, it identifies the process factor that improve the quality characteristic, and it minimizes the sensitivity of the design to source of random variation. Okay, to make it easier for you, this is the orthogonal array of control factors. So the parameter design just now, actually it indicates two-way interaction between all control factors. So we use the orthogonal array for a clearer view on the interaction. So actually there are many types of orthogonal array, but the one that we choose for our experiment is the L9 because it is the most suitable orthogonal array that to understand the effect of four control factors on three levels. So this is how you read the experiment. So for example, if you look at experiment 1, we can see that all four control factors are at level 1. So but if you look at experiment 4, control factors for A is going to be at level 2, control factors for B is going to be at level 1, control factors for C will be at level 2, and control factors of D will be at level 3. So that's how you read it, and that is how you know which control factors and at what level are they at. Okay, next we use the tolerance design. So tolerance design is the acceptable range for a physical dimension which is determined by the product designer based on form, fit, function of the part. So in this experiment, we are the product designer, and about the acceptable range, actually this is because when we fly the plane, we will record the distance and then we will calculate the result. Okay, next, it sets the tolerance around target value with the consider of the performance variation. So, but there's no target value in our experiment because the aim itself is to find the plane with the furthest fly distance. Okay, and lastly, tolerance design is to deal with problem of how and when to specify tighten tolerance for a product or a process so that quality and performance or productivity are enhanced. So when we were conducting this experiment, we can see the difference in flight distance. So that's how we get to rate their quality and with better, so we can see which and what design has the better performance and which can we enhance. So while conducting the experiments, so firstly, we have different noise factors because all our members are taking part in flying the airplane. So we have different noise factors because some of us are uh, conducting the experiment on a field. Some of us are conducting the experiment on a big room. So the different noise factors actually affect the performance of each airplane. Then, after we conduct the experiment, the mean from the flight distance results are calculated, such as the mean distance, the mean standard deviation, mean signals to noise ratio. And we're using the bigger SN ratio, signals to noise ratio, the better. It is because we want to find the one that maximizes the SN ratio because we want to find the airplane with the furthest flight distance. For all the formulas that being done to calculate the result will be explained later on in methodology.
Before lecturer review, Taguchi method has a good quality control in the manufacturing industry. The concept of Taguchi trained engineers to consider quality as a yardstick in their design of process and products. There are three basic concepts of quality has promoted to make improvement in development and application of technology in manufacturing. First, minimize the deviation from the target and product to achieve the quality and design the product that is uncontrollable by the environment factors. Second, the load should measure across the system and measure the cost of quality as a function of deviation from the standard. The last concept is the quality should be designed into the product. The concept of loss function. The Taguchi method allows how to measure the quantity of cost and benefit. This can be used to evaluate the potential savings throughout the experiment if the product design is the optimal condition defined by the Taguchi design. Taguchi loss function is used to accommodate all features with different measurement units and scale set into a common measure. The Taguchi loss function indicated the most significant difference between the actual process and the goal requirement is due to quality work. According to Taguchi, the bigger the deviation from the objective, the greater the risk of failures as well as the quality cost and repeat rate. Any difference between the job value and the actual value will lead to the loss and it will result zero loss when characteristic measure equal to the target value. In packaging method for robust design, it enables a large range of manufacturing tolerance, more flexible working environment, and a lower waste components and materials. There are two main tools used in robust design which are signal-to-noise ratio to predict quality from a customer perspective, and auto-level array to study a large number of precision variables with a small amount of experimentation. As a result, the most economical products and process design for a manufacturer and customer perspective can be completed with a minimal and incremental development cost.
I'm Khairunnisa binti Khairuddin, my method number 272179. In this part, I will explain about our methodology for this project assignment. Design of experiments using Taguchi approach. In order to demonstrate a Taguchi photoreal experiment, the design of experiment Taguchi airplane proposed or using Taguchi method. Signal to noise ratio are log functions which this technique is using orthogonal arrays which is provide a set of balanced experiment and output. Also serve as objective function, data analysis and prediction of result. This method will select data at the arrays by looking two items which are the number of variable and the number of state in this experiment. So the shape and the size aeroplanes of the array are depending on the value of parameters. By this, Taguchi's parameter design is the important quality tools for robust design. There are two major tools that have been used in robust design, which are first signal to noise ratio and second is the orthogonal arrays. This method gives opportunity to testing the effect of four factors by each have three levels on the flight distance of our paper aeroplanes. Then, data analysis that we get will combine with a T1 experiment that need to be performed. Here, we can see that there are two, which are first modeling mathematics and signal to noise ratio. First, modeling mathematics. This experiment, we will use Taguchi method based on orthogonal arrays. It's knowing as the number of parameters and level which is arranged by proper orthogonal array that can be selected. Second is the signal to noise ratio. This formula is using in this project to consolidate several repetitions which at least have two data analyzed, which are value of parameter and the level, calculate into value of amount variation present. These signal to noise ratio are depending on the type of characteristic as showing at the slide. In this project experiment, the result of data analyzed by using Taguchi method proposed to answer of the following question discussion, which are first, what can you say about the effect of the different factor on flight distance? What levels of each factor will you use to maximize flight distance? Second, what can you say about the effect of the different factor on variation in flight distance? What levels of each factor will you use to minimize variation in flight distance? Third, is SIN ratio are reasonable ways to capture both goals to maximize distance and minimize variation. Can you specify an optimal design? Why and why not? Four, what types of noise variations are considered in this experiment? And the last, fifth, how can interactions between factors be considered?
Hello, my name is Taguchi. My matrix number is 271775. I will present about the data analysis and discussion. Firstly, we can see they have two tables in data analysis. First, The table above is Taguchi airplane flight distance record, and the table below is Taguchi airplane design analysis table. Based on the table 1 and table 3 above, it shows all the 9 experiments and 9 repetitions for the flight distance record and all the factors which are weight location A, stabilizer setting B, nose line C, and wing angle D. The 4 different factors have an effect on the different flight distance. In addition, the table above shows the average distance flown at each factor level. From the result of the table, we can see the wave location at level 1 A1 has the highest effect on optimizing and maximizing the flight distance. Stabilizer setting at level 1 B1 has the highest effect on optimizing and maximizing flight distance. Nose line at level 1 C1 has the highest effect on optimizing and maximizing flight distance. For the wing angle at level 1 D1 has the highest effect on optimizing and maximizing flight distance. Therefore, the highest mean of flight distance is A1, B1, C1, and D1. Based on the table above, it shows all the factors which are wave location A, stabilizer setting B, nose length C, and wing angle D. The 4 different factors have an effect on the different flight distance. In addition, the table above shows the average distance flown at each factor level. From the result of the table, we can see the wave location at level 1 A1, stabilizer setting at B1, nose line at C1, and wing angle at D1 has the highest effect on optimizing and maximizing flight distance. The level of each factor that we would use to maximize flight distance is level 1 for wave location with a mean of 345.89. The stabilizer setting is level 1 with a mean of 364. The nose length is level 1 with a mean of 313.33. Lastly, the wing angle is a level 1 with a mean of 295.67. Therefore, the highest mean of flight distance is F1, B1, C1, and D1. For the question 2, from the result of the table, we can see the wave location at level 3 A3, stabilizer setting at level 1 B1, nose line at level 3 C3, and wing angle at level 2 D2 has the lowest effect on optimizing and minimizing flight distance. The level of each factor that we will use to minimize flight distance is level 2 for wave location with a variance of 342.99. The stabilizer setting is level 1 with a variance of 597.31. The nose line at level 3 is with a variance of 351.56. Lastly, the wing angle is at level 2 with a variance of 536.85. Therefore, the lowest variance of flight distance is A3, B1, C3, and D2. For the question 3, the answer is yes. SN ratio is a reasonable way to capture both goals, which is to maximize distance and minimize variation. In the design of experiments, optimal designs are a class of experimental designs that are optimal with respect to some statistical criteria. Optimal designs to maximize distance are A1, B1, C1, and D1, while optimal designs to minimize distance are A3, B1, C3, and D2 to achieve both performance and robustness as a whole. This is because mean and variance are combined and expressed as a single objective in the form of a single to noise ratio is defined as Sn equal to 10 log mean divide standard deviation square, including both the desired signal performance and the undesired noise effect. The signal to noise ratio must be maximized in order to achieve higher robustness measurements. Taguchi experiments also use the two-step optimization process. In step 1, use the signal to noise ratio to identify the control factors that reduce variability. Next, step 2 is identifying the control factors that move the mean to the target and have a little or no effect on the signal to noise ratio. For question 4, type of noise considered in this experiment is noise factors. The noise factors used in Taguchi airplane design that can classify control factors such as control by the process and design decrease variables in the product by minimizing the effect of noise factor. Example of noise factors are temperature and humidity. Noise factors are factors that cause change in system or product performance, but they cannot be controlled during production or product use. However, they can control or simulate noise factors during experimentation. This is because when someone used the noise factor in the experiment designed by Taguchi to identify optimum control factor settings that make the process or flexible product to noise variation. The higher signal to noise ratio levels are thus the effect of the noise factor will lower. Noise can be classified into three major categories, which are internal noise, external noise, and between product noise. Internal noise as a result of aging, such as wear of the device and aging of the material, while the external noise is due to environmental conditions used by clients and more, such as temperature, weather, intensity of wind, and more. Last, for the between product noise is related to piece of preparation for product design where they are needed to be same. For the question 5, the main purpose of Taguchi's design is to study the main influence of factors. Certain Taguchi designs orthogonal arrays allow us to study a limited number of two-way interactions. This usually requires us to leave some columns out of the array by not assigning factors to them. The interaction between some array columns and other array columns is confused. Confusion refers to the combination of factor effect and interaction effect, so they cannot be accessed separately. The orthogonality was given in Table 3. The table above shows total 9 experiments, and each experiment are based on the level values combined. For example, wave location for the first experiment is at level 1, stabilizer setting is at level 1, nose length is at level 1, and the wing angle is at level 1. For another experiment, which is 6th experiment, the wave location is at level 2, stabilizer setting is at level 3, nose length is at level 1, and the wing angle is at level 2. The table below show the linear graph above show the available interaction between the 11 given variables and factors. A1, B2, and C5 are categorized as a factor by the array column, and the connecting line is 3, 4, 6, 7, and 8, 11 as the column for the interaction. This graph shows a possible study of one interaction is between factor A, factor B, and factor C.
So here for the conclusion, we can see that the Taguchi method determined through the level of the factor, which is a weight collection, stability, nose distance, and weight angle that affect the quality characteristic. So here, industry need this method or this approach to conduct the experiments, which optimize process and increase the quality of the product. For this, after applying this method in this project, we see that the design of the aeroplane Taguchi experiments is the basic step of quality improvement via optimized processes. Besides that, a set of experiments in which all the parameters are vary over the specific range also is much better method to obtain systematic analysis data based on the experiment. We use Taguchi method in this project to analyze experimental data from the flight trials design record and to find the optimal parameter combination with the different design of the paper airplane. The result data collect show the experimental and analysis process from which an optimal set of parameters was determined. So before we end our presentation, we include a short video on how we carry out our the whole experiment.